Welcome everyone to day 2 of the Breakthrough Festival, a celebration of women in STEM. My name is Nicole Williams and I will be your moderator for tonight's event. As we're getting started, if you guys could continue posting in the chat where you're joining us from today, the chat can be located on the right-hand side of your computer. And while everyone's doing that, I'll just introduce myself. So I am the program manager at Brown University in Providence, Rhode Island. I also run the Women in Science and Engineering peer mentor programs, as well as a peer mentor program for historically underrepresented students in STEM. I'm also the PODS program manager at 500 Women Scientists, and I help to bridge the gap in communication between the leadership team and the pod coordinators. And I'm also the co-founder of a new initiative called the Black Women's Collective. To learn more about 500 Women Scientists, you can visit our website at 500womenscientists.org. Being a part of this particular event is very important to me because this month we're also celebrating Black History Month. And I can't think of a better way to celebrate than to highlight two amazing women in the STEM field. Our partner for this week is Science Friday, a nonprofit radio production distributed across the country. They also produce original web articles, live events, educational resources, and digital videos, like the ones we're here to celebrate today. You can find out more about the Breakthrough series and the whole week of amazing programming by visiting sciencefriday.com/breakthrough festival. We also want to take a quick moment to thank our sponsor for tonight's event, Tucker Davis Technologies. TDT designs and manufactures products for neurophysiology, hearing, and speech sciences research. You can find more information online at tdt.com. Thanks again to everyone at Tucker Davis Technologies. And you all can join the conversation online using the hashtags Breakthrough Festival or tag at 500 Women SCI and at SciFri, SCIFRI. So with that, here's a quick summary for tonight's festivities. We'll first start with a quick introduction to our two guest speakers, followed by brief clips from the breakthrough videos featuring them, titled The Trauma Tracer and The Killer Snail Chemist. Then we'll launch into a set of prepared interview questions, and throughout the event, let us know if you have questions for both of our speakers in the chat. Our producer will be collecting your questions and we'll ask them throughout and at the end of our time together. So without further ado, I'd like to introduce Mandë Holford and Bianca Jones-Marlin. So Mandë received her Ph.D. in synthetic protein chemistry from Rockefeller University. She is now an associate professor in chemistry at the City University of New York Hunter College and the City University of New York Graduate Center, with scientific appointments at the American Museum of Natural History and Weill Cornell Medicine. Her lab investigates how venom in marine snails can treat human diseases and disorders. Hi, Mandë, welcome.
Hi, Nicole. Fun to be here tonight. Thanks everyone for tuning in.
So let's first start with a quick clip from the breakthrough video that features Mandë, titled The Killer Snail Chemist.
As a kid growing up in New York, you have a couple of places that are really special, and the American Museum of Natural History is one of those for me. We would go to the Museum of Natural History and go on our adventure roaming through the halls. Each hall was like a new adventure. What I didn't understand as a child then was that was science. It has a special place in my heart to be a scientist. Almost every natural history museum on the planet has a shell collection. You can learn about biodiversity, you can learn about the family trees of the snails, and look at how venom has evolved over time. The snails that we work with, they're not garden snails. These are marine snails. They're found in tropical marine environments all over the world.
Great, so that was awesome. And let's welcome our second guest. Bianca received her PhD in neuroscience from the New York University School of Medicine. She is a neuroscientist and an assistant professor of psychology and neuroscience at Columbia University, and she recently opened the Marlin lab at Columbia University's Zuckerman Institute. Bianca is investigating transgenerational epigenetic inheritance, or how trauma in parents affects the brain structure and sensory experience of their offspring. Welcome, Bianca.
Thank you. Thank you for having me. Thank you, Nicole. Hi, Mandy.
Hey, Bianca.
And we'd also like to play a quick clip from the breakthrough video that features Bianca titled The Trauma Tracer.
I had the amazing opportunity to grow up in a very dynamic family. My biological parents were also foster parents. And so I had the opportunity to grow up with many siblings.
You've had over 20 some odd siblings living here. They learned to work with each other. They had some good days and they had some sibling days.
And then when we went to bed, I heard where my siblings came from and what they had to go through in order to be put in foster care. There were stories of abuse, of not getting the proper nutrition, the proper care that a child would need. Young kids shouldn't always have to go through the things they go through. So I almost feel as if it's my obligation to, I don't know, do something about it. Taking my passion for science and what I learned from them and putting them together is really my end goal.
Thank you both so much for being with us tonight. So I'm going to begin with a question that I have for both of you. And in the meantime, audience members, if you have a question for either Bianca or Mandy, please put it in the chat and I will ask it. So Mandy and Bianca, when did you first become interested in science?
Oh, for me, it was in undergrad. And it was particularly my undergrad professor, Dr. Johnson. He came in and showed me that science was this world of experimentation and discovery. And he was a physical chemist using lasers to burn holes into molecules. And we made liquid nitrogen ice cream. And I was gone. I was like, this is so beyond anything I thought science was. Because it was always taught as something we know, right? Like we know the planets, we know the organelles, we know. But what science really is all the things that we don't know. And it's that wonder of discovery that made me want to become a scientist.
I would have to say I can't pinpoint a time, but reflecting back on my childhood, I have to say, as you heard, I had many siblings growing up. And I think that led to a lot of independence. My parents were like, yeah, go play. Go do something. And so that made us like go out in the backyard and we would dig in the backyard garden. I grew up in Long Island and I would find frogs like underneath the ground, or my dad would let me work in his workshop. My dad is a carpenter of many other sorts. And so he'd let us like play with the saws and play with the electrical soldering and make jewelry out of them. And these were all aspects of us entertaining ourselves. And similar to what Mandy had said, and as an adult, you realize, wow, like I'm an electrophysiologist. I use TDT technology. I was doing soldering, as a third grader. And so it really was just and something I found so entertaining in life.
That's great. So what makes science fun for you both?
I think for me, it's the discovery. It's the fact that you can find out something that no one else in the world knows, right? You can find out something that no one else on this planet knows, that you have the opportunity to add knowledge. And especially for me in biodiversity, when you get to name species and you get to name an organism, that is in the history books. And that's your contribution to science. And you've done something different when you've discovered a new species or you found a new organism somewhere. That to me is just the opportunity to explore our planet and to discover what's here and find new things.
Yes, and I have to say along similar lines, science pushes you in a way that's slightly uncomfortable. My favorite part is also the most terrifying part. My favorite part is saying, like, I have this really cool idea. And I think if it works, it's going to be really, like, other people are going to think this is amazing. That's also equally terrifying because you're hedging your bets on at this point, at our careers, for this like hunch that you have, for this inkling. But it's so enthralling when you see that come to pass, when it goes from an idea to either you or the hands of your students and mentees putting it together. And then you see at the end, oh my gosh, as Mandy said, I've found something, I've created something. And it just helps build, it's like a positive reinforcement over a long period of time, but a positive
Long
reinforcement.
period of time.
Long period of time, but a positive reinforcement that allows you to, ask that next really like weird or interesting, exciting question.
Yeah.
Awesome. That's wonderful. So how does your work help to encourage more diversity in STEM fields?
The work research-wise, or like what we do in our lives in general? Like,
I would
which
say
aspects?
research-wise, like
Research-wise.
in your labs.
I mean, I don't want to speak for Mandë, but I'm going to suggest
Go ahead.
that our presence increases diversity, because the sheer fact that we are in a place where we don't reflect the population of, I'm presuming, but black presenting women in the population is not reflected in science. Our sheer presence invites others to say, we're here, we're doing well, we're thriving and surviving, which means it's a place that potential to be welcome to you. And I try to practice that in my, as you heard, I transitioned from a postdoc, and I'm now a PI only for the order of maybe 40 days now. Thank you very much.
Exciting.
It's official. It's
Awesome.
official.
That's great.
My friends are already like, oh, so it's cool, right? Because I'm there. And emails from students being like, there's such a motivation for standing. I'm just doing what I love. But my presence there is recruiting like Black and brown and underrepresented students. And I think it's also reflected in our science, of course. Our science is our heart, right? What we have in our heart, and that's a part of our identity. But also just us navigating this world is enough to increase that.
Right. Okay.
I would have, I 100% agree. And speaking as someone who does field work and goes out on expeditions, very rarely do I run into an expedition. You're called the chief scientist if you're leading the expedition. Rarely do I run into another, scientist of color or female scientist leading an expedition when you're out in the field. And I wholeheartedly agree with Bianca. Us being there sort of is a mirror for what's possible to a lot of people, right? The whole see it, be it thing, I think, is a real phenomenon. And being able to, for me, it's always been a sort of a tuggle, because no one wants to be a role model, right? Who wants to be put on a pedestal and not allowed to fail and not allowed to have bad hair days or not wear the right thing or say the right thing? Nobody wants that. Your hair looks great, girl. Nobody wants that at all. Nobody. Right. And so, but because there's so few of us, you automatically are that, whether you want it or not, right?
Absolutely.
And so many young people will come and want to work in your lab or want to, talk to you or ask you questions simply because who you are. And so in that instance, it's not even about the science. It's more about the scientist and who we are and what we're doing. That is the motivation for why we're increasing diversity, is the fact that we're there, right? And that we have these lived experiences that are different. But then particularly in the field that I'm working in chemistry and biodiversity, there really are so few. And the questions that we're asking that I think makes the inclusion more is the fact that I come from a background that is very sort of, integrated and interdisciplinary. And the kind of science I practice is interdisciplinary. So to me, more is more. So if I meet someone and they want to collaborate, we'll figure out how to make that happen. I'm not thinking that there's only one way to do science or there's only one way to be. I think there are many ways to do science, and it's reflected in the kind of science that I do. We study everything from, phylogeny to nanoparticles, and it's because those are my interests. I'm curious about the world, and I'm curious about how to make science, innovative and how to do things differently. And so when I approach science from that aspect, I'm being very inclusive, not only in the disciplines that I study, but in the scientists that I choose to work with.
So I'm looking at our audience questions, and we have a few. So let me ask this question from Sharia. She asked, did you enjoy science class in grade school?
I don't know. I'll let you go, Bianca. Go ahead.
Are you sure? Because maybe I need to with a positive buffer, because I definitely enjoyed it, but it was not my forte. And I think that was a really hard decision to make, especially going into college where you have to take, if you're going to be pre-med or doing science, you usually have to take like something like organic chemistry, orgo. I loved organic chemistry. I loved studying the way these molecules work and were formed. My grades did not reflect that.
I was going to say, you might be the only one that loved organic chemistry.
No, I loved orgo too.
It was
just me then.
But and I had to make a decision. Am I going to go with what my grades reflect I'm good at, which was English. I was excellent always in English. But the math and the sciences really posed a challenge for me. And in retrospect, I'm really proud that I stuck with that, even though it was the lower part of my GPA from high school all the way into college and even grad school. I'm happy I stuck with it because I get to learn it now in my own time in a way that's not like I don't feel pressured by the test or by the exam or by the what do they call it? Back in the day when I was in college, like the curve. Yeah, I don't have to worry about that. I can read it and understand it at the time.
Funny.
So I enjoyed it, but you wouldn't have known based on my grades.
Sure.
Yeah, so we're exactly polar opposites in this, Bianca, because I always tested well. I went to Brooklyn Tech. I was in gifted and talented classes, all of these things. But it wasn't because I liked it. It was just because it came very easy to me to do these exams and to do well. It wasn't until really college that I was focused on, this is something really cool. Like, it's not just, rote memorization and repeating what they want to hear on the exam, or what, filling in the scantrons and the bubbling and the whatever to find the right answer. And it wasn't till orgo, when you're like, this is really neat. Look at how these molecules move. You can figure out the mechanism by pushing electrons through. It was like, oh my God. That was sort of the awakening for me. But it wasn't but again, so we're like opposite in that I always tested well. And so I was always pushed towards math and science by educators. But it wasn't something that I was like, oh yeah, this is gonna be fantastic. I wanted to be really a track star because I was an athlete in elementary school through college. And then I went to like Penn relays and had the ultimate fail. And it was like, maybe science, maybe they're right. Maybe they're right.
Do you still run now?
I still run. I'm sprinter though. I don't do distance.
Okay.
Now I'm just running to keep up the kids.
Yeah, and I was in marching band, so there goes that.
No, I'm just kidding. Oh, that's funny. So let's get a little bit into both of your research that you do. So Mandë, how did you originally become interested in studying marine snails and their venom?
So I was really interested in working at the American Museum of Natural History when I was doing my Ph.D. at Rockefeller, but they don't really hire, physical chemists or organic chemists or synthetic chemists or chemists really. And so I had to find an organism that had like a legit natural history story that also made peptides. And so that sort of led me to venoms. And then the choice is, sort of, do you want to live on a beach or do you want to live in the desert? Where do you want to go? Right. Scorpions and snakes, or, marine organisms and diving. Right. So I chose the marine organisms and diving. But also it's also because I had a great mentor in postdoc, Toto Oliveira, and I call him the godfather of snails. And he showed a video of a snail eating a fish, similar to what you see in our breakthrough video stories. And it just was like amazing. I was like, how is this possible? If anywhere there's an innovation in nature, it's that a slow moving snail could eat a faster moving fish. And so it's like, all of this is possible by peptides and other things. But for me, it was peptides. Peptides are making that snail eat the fish. I've got to find out how. And so, that led us on to the yellow brick road that we're still clogging through.
And a follow-up question, Mandë, can you talk about how venom in snails could potentially cure cancer?
I know. It seems like the two should never meet, right? Seems like you should never be using venom to treat anybody anywhere. But it is definitely possible. Because what's unique about venom is that it's it's very selective, or it can be, the venom components can be very selective for particular targets. And so we know that on tumor cells, they have, you might hear the little one crying in the background.
No worries.
On tumor cells, we have specific targets that these venom particles are attracted to. And so if you want to make a selective therapy for cancer, something that is selective to tumor versus normal cells, these venom peptides are actually quite an effective route of looking at them, and quite a unique and extraordinary way to go about doing that.
Wow, that's really cool. And I have a question for Bianca. How did your home life influence your desire to become a neurobiologist?
Similar to the sounds we hear in the background. I'm also a fan of peptides. My doctoral work looked at the peptide oxytocin, and peptides are just amino acids that are chained together by something called a peptide bond, and so they make bigger, larger molecules. So I was a nanopeptide fan, and looking at oxytocin, which is like the love drug, quote unquote. It's known to play a role in maternal behavior, and my focus on maternal behavior, if I take a step back, has to do really, and I only found this out really in grad schools. I realized what I was gravitating towards, how interactions with our parents play a role in our learning. And this is twofold. I was a teacher before I started in grad school. I taught at a school in the Lower East Side, and I was a biology teacher for 7th grade, 10th grade, and AP biology. And I couldn't separate the fact that some of my students were just gung-ho. Some of them wanted to be gung-ho, but certain things outside of their school life just caused them not to. And paralleling that with my home life, in which I observed my siblings just struggle with relationships with their parents. And I think those two things came together when, how do you make people optimize the learning? Because education, as we know, as Americans, is just so important for us to attain next steps. And it's not always attainable. We see it in New York City, we see it across the United States, specific to this kind of heart, seeing that for my students, like, how do I make that better? And so those two came combined with, how do you learn? And also, how do your external factors help you learn? And specifically the parental factors. So my doctoral work looked at how moms, mom mice, how they play a role in taking care of their pups and not, and how the nanopeptide oxytocin changes that. And here comes in TDT, because I recorded in hearing centers of the brain and saw that moms have a different hearing center neuronal response compared to research.
Great, awesome. So now I'm going to take a few audience questions. So Nelson Smith asks, any unexpected discoveries while doing your work?
For me, it was that these terebrid snails had such diversity in their foregut anatomy. So it's kind of like thinking of how many ways can you kill a fish, or how many ways can you consume the fish. In their foregut, they have venom glands and salivary glands, and all of these different ways of either producing toxins or not producing toxins, but still being able to extend this weird looking structure that we call the accessory proboscis structure, so it can engulf a worm. We found, I think currently we're up to like 12 different anatomy types in these snails, which to me is a world of diversity in terms of speciation and morphology that needs to be explained, right? So it's sort of like you go down the rabbit hole and trying to figure out why this one little snail has so many different ways of doing something. So it's a little crazy.
Yeah, should I answer that question as well? Do you want me to chat about
Yeah,
that?
sure, go for it.
I mean, I think something that really excited me was learning about something we call lateralization. So I found that oxytocin, the thing that makes oxytocin work, the molecule work, is called a receptor, and it's on top of the neurons. And my work showed that there's a lateralization of those receptors. So there's more on the left side of the brain in mice and mammals, that my mom looking at as mice, as opposed to the right. And why that was so cool is because people speak about in humans, Broca-Wernicke area. This is an area of like expression and understanding. And it seems to be lateralized in humans. And considering that oxytocin is real social hormone, I found a link between social molecules, social hormones, and the lateralization we see in anatomy. I thought that was like so cool, fun, and exciting. And it's something that we also live for, just finding that new cool thing. I would like now, formerly as a postdoc, one of my students came up with this idea, and she just like took it and ran with it. And it's one of the biggest part of my lab now, just having thought and an experience and saying like, I wonder what this would look like, on paper with data. And it's just so exciting to see that go forward.
Oh, wow. So here's a fun question. Do either of you have a favorite book about your area of expertise? And that was sent in by Denny.
Oh, yes, I do. It's Vermeer's book, and it's he's a blind malacologist. When I started my postdoc after I left Rockefeller, and I was at the Paris Museum of Natural History, learning all about shells and learning about taxonomy and phylogeny and what it means to be a malacologist. And someone gave me the book of Vermeer. What's it called? Oh, the title is escaping me, but I think it's something with hands. But Jarit Vermeer is this blind taxonomist who can, he really came up with the theory of the arms race, where he studies the sculptures on the morphology of the shells and came up with the idea that, these two species are sort of co-evolving to gain dominance over each other. And so this arms race, which is like the queen bee hypothesis, queen bee, not Beyonce, queen bee, something else. Although she is queen bee, the ultimate. but his book, Privileged Hands, that's the name of it. Privileged Hands. It's an amazing autobiography because it tells his story, and his mom never let him, practice as seeing his blindness as a deficiency. She always told him that it's going to be something special and you have to go out and do everything like everybody else. And I met him for the first time. When was it? I think it was it last summer? I can't remember. But I met him just before, the whole horrific shutdown happened. And I was like in awe because it was amazing to actually meet someone you've read their life story and you've read their papers and you know about them in the field. And it's just amazing that they're able to do that. The other is Bruce Merrifield, who sort of started solid phase peptide chemistry. He has an autobiography, The Golden Age of Peptide Synthesis, I think his book is. And it was weird because while I was in grad school working on the 3rd floor, he was on the 4th floor of Flexner. And it's like, wow, again, you meet people who have changed the field and who have really, brought something forward that no one else has done before in ways that are so dynamic and so forceful and breakthrough. And when we want to talk about breakthrough. And those two scientists, I think, for me, were phenomenal. And their autobiographies are so well written that I encourage everyone to go out and look for them.
And then Bianca, do you have a favorite book?
Okay, so you've changed the questions and I can give you an answer. I do have a favorite book.
Yeah.
Genetic inheritance. Okay. Because when it comes to science, you said that and I was like, oh my goodness, I can't put my finger on one. I guess like the textbook from grad school. I couldn't put my finger on one. But I would say my favorite book overall has been Native Son. And I think what really makes my heart I remember reading it. I first read it in high school and I feel like I was having I felt the character's anxiety. And it had to do with the social relationships that the main character had with society. And I think my real love is in social relationships. That's why I study oxytocin and relationships of your ancestors, how they live in you, because it's such a strong human drive, mammalian drive. I would even venture to say drive of snails. Snails have chronopressin, which is an analog to oxytocin. So there is some component of social acknowledgement that's in all of us. And I think that book tugs on my heart so much. I can't really read it now as an adult. It's too much. It just makes my heart race too much, but it's my favorite.
Right, so we have a question from Shannon Fay. She asked, both of your work deals with studying animals to better help humans. So what are some connections between either mice or snails to humans that surprised you?
I would say for the mice work, and I want to venture to say, I know I'm studying trauma throughout generations. But in the lab, this is very well controlled. So we have veterinarians who can say yay or nay to everything that we do. All of the traumas, I'm not like, putting mice through traumas I've seen my siblings go through. This is something that's very well controlled. I want to preface by saying that. And by saying that, I will say that I think what I found most fascinating was parental behavior. Just when I first started working, I worked with rats originally, and the way these mothers would fiercely fight for their offspring, even if I was just going to touch one, I was like, you know what, you win. I'm going to step back. I'm not messing with your little ones. It's like the little baby lion came out of these mice and then out of these rats. And it's so cool to see that that's evolutionarily conserved, that we can maintain our genetics, but also it kind of be seen as like, you care enough to take that initiative. So I would say parental behavior.
For me, I would say habits. We sometimes, especially when I was in Toto's lab, we would have snails in tanks, and we would feed them, fish, and keep them alive for either outreach when students would come by, or just to learn about the ecology of how they feed. And like humans who can quickly develop habits, whether it's smoking, drinking, or Beyonce concerts. These snails, they can develop a habit for, when you feed them, how you feed them, and some of them can get very particular. And I was surprised to see that it was very easy for them to get trained in terms of the feeding schedules and getting the habit of what to do and how to perform. Some snails, when there were groups outside of the aquariums, they would crawl up out of the sand, because most of the time they're buried in the sand. You don't see them.
Right.
And some you'll dig up and they'll just go back down. And then others, it was like, the seal show at Central Park or something, the sea lions, they're ready to perform. And so I was like, oh, okay. So yes, personalities and habit forming things, just like humans, exist in snails. Wonderful.
So did you see that, like, when people would come by the tank, they actually would like come out of the, like, they acknowledge your presence, kind of like, hey, I'm here.
Some of them would, especially if they were hungry, right? And it's like eating time.
Makes sense.
I wouldn't think they would even sense my presence. I think that's so cool that you could be like not moving the sand or anything, and like they see you and they're like, oh, food time.
Right.
It's more shadows on the aquarium, probably, that they see different shadows as someone's passing by.
Yeah, that's
but it really is sort of like,
though.
if you've seen the feeding in the Central Park Zoo of the penguins, how they'll get near the door when it's about feeding time, and they're like, come on, send the fish in. It's the same kind of thing. They all crawl out of the sand and they start like, okay, it's about time. Where's the fish? Let me have it.
Very cool. So Teresa K asks, what is something you feel is misunderstood about your field, specifically about your experience as a Black woman within the field, or anything else that comes to mind?
Oh, we have to think on this one. Wow. Misunderstood. I think I would say what may be misunderstood by maybe people who haven't gone through the scientific process is time. How long it takes from conceiving an idea to, and in science, our currency is one of our currencies is publication. So how long it takes to get a paper out to the scientific, a peer review, which means other scientists looked and said, thumbs up, this is good. I trust these data out into the world. And that's because we want to make sure we're putting things out into the world that are true, that align as close to truth as science can. And that requires rigor, that requires time on time, repeating experiments. Sometimes it requires late nights. Sometimes it requires like odd times, like weekends. And hopefully not so much now that as a principal investigator, I have students who are doing that hard work, and I get to check and thumbs up. But as a graduate student and postdoc, it requires, sometimes you get so into it that it leaks into your life. So the time and how over consuming it sometimes can be. And I think that just has to do with us making sure that we put those boundaries up when it comes to like having kids or like having friends or having a partner and other things just to live in life. And also being okay with the fact that this may take a while, but in the end, it's going to be worth it because you've contributed something that was not formerly there in the scientific community. And now it's there forever. Yeah, I would say time as well. And in our instance, it's more about time of how long it takes to make
drug or a therapeutic. Everybody thinks that, because they saw it in the mouse, that tomorrow or next week, we're going to have a drug. And it does not work that way. The one snail drug that's on the market was, the peptide was identified in the early 80s, and the drug wasn't approved till 2004. So it took, umpteen of 20 plus years. And I think that's something that people are always shocked about. Is how slow therapeutics are made, and how slow, and especially in this last year, because the vaccine, I think if you had asked a lot of betting scientists if we'll be able to make this COVID vaccine in a year, most people would have said, no, I don't think so. I don't know if that's going to even be possible. Based on the history of drug development and therapeutics, right? It usually takes several years to bring a drug to market. And so what these scientists at, Pfizer, Moderna, and all the other companies have accomplished is really extraordinary, really extraordinary, that they're able to bring a vaccine this quickly to market. Yeah.
I think that's a direct reflection of just minds coming together. It's a motivation, collaboration, more so than anything else. Like, I'm speaking about time, and I'm speaking about time of an idea that I have that maybe I'll have a graduate student or postdoc work on, or I'll work with a friend in science with, but that's two people, three people, not full on corporations putting together. So if they can come up with a novel vaccine, this is not a regular old vaccine. Like, this is an RNA vaccine, which is different. A novel vaccine, because humanity needs it. I think it motivates us as scientists to say, like, maybe we should talk a little bit more, because humanity needs our science too.
Right.
Exactly. And it also shows that, if there's a will, there's a way. So like the question about, diversity in STEM, if there's a will, there's a way. If there's a will, if there's leadership, and if there are funds for it, then I don't think that we will continue to have, disparity in STEM in terms of race or gender or anything else. But there must be leadership, there must be a desire to do so, and there must be funds behind it for it to happen.
Right. So Jeff Grant asked, is there any new data in either of your research studies you could share with us now since your Science Friday video?
Well, I think for us, the new thing that is really exciting and very cool is the idea that you can have venom gland organoids. This was sort of a breakthrough from Hans Cleaver's lab early last year. And it's something that I think is going to sort of revolutionize the way in which we study these venom glands. So, Bianca has a nice model system with the mouse, and she can go in and do things. We don't have a model system with the snails. You can't breed them in the lab. You have to sacrifice them to get the glands out. And you get very tiny amounts. It's not like snakes. Snakes are like the superstar. Everybody's like, I work with snakes, Yeah, great. Because you can milk them and you get milligrams of venom, and you can go in and do a whole bunch of things. But with snails, you get like tiny amounts of venom. And so developing a model system, especially an organoid model system, or even a viable cell line, which we don't even have, right? So being able to do those two things would really be game changers, not just for the snails. I think making a biobank of all of these different venom glands would really be game changers for how we can study this really phenomenal innovation that nature has done, venom, which is found all throughout the tree of life. And so for me, I'm super excited about that possibility of doing that in our lab in collaboration with Hans's group, and really trying to see if we can make this sort of model system for how we study venom that can tell us everything from evolution to giving us, things that can cross the blood-brain barrier, things that can be very good at therapeutics, So for me, I think venom right now is at a very exciting time, and I encourage you all to join in the killer venom snail world. And let's all do great things in the next 20, 30 years together. It will be, I think, a phenomenal time.
Amazing. I want to share, Jeffrey, you asked that question. Thank you for asking that, because I want to share my thought process with that. You said since the video came out, and I went through my mind like when the video came out, we started filming end of 2019 and where we are now. And I paralleled that with my life. And I was like, whoa, I became a professor. I gave birth to my son that is 8 months old now. And I also survived a pandemic. And I got 3 pieces of data. And it's not saying it's like it's wrong. It's like I'm excited. Like in that period of time, with so much going on because science takes so long.
Mhm.
I also got some stuff done, which is super exciting.
Yeah,
And
you've done a lot. Yeah.
it may not be as much of a jump as one would predict, but I will share that we got the opportunity to look at other sensory modalities. I currently was looking at hearing and smell, and we've also incorporated other sensory modalities, taste, and maybe even touch into our thought process, and started to get preliminary data with that, as well as neuromodulators. So these are chemicals that are released from the brain that can maybe dictate the way neurons fire, and maybe dictating the way that these changes occur. So just taking those small steps to start probing those mice are actually massive steps considering the time span in the science time.
Great. So Rebecca Barnes has a question. In both of your videos, and just now, you all do such a good job of communicating super complicated science. How did you learn how to do this?
Trial by fire.
Thank you, Rebecca. I cut you
For
off.
me, my family doesn't have a science background, I think similar to Bianca. And so whenever you wanted to go home and talk about what you're doing, you had to find ways to make it relevant that people won't tune out right away.
Right.
It's
Yep.
like, okay. And then I'm one of 5 kids. I didn't have 20 siblings, but we were a full house, right? And so if you wanted some attention, you had to figure out how to speak about your projects in ways that people won't
That's
be
funny.
like, oh, okay, no, next. and I think a lot of practice too, right? So there's a lot of practice that goes into learning to talk about your science in a way that's relatable. And a lot of that practice I got at the American Museum of Natural History, doing programs with the education department and running after school science program there when I worked right after grad school, and continuing to do science outreach and science communication in many ways. And even with Killer Snails, the edtech company that I co-founded, the whole idea is to try to make science accessible, right? Because I think that's one of the biggest misconceptions is that not everyone can do science, and it's so wrong for people to think that, because we can all do science. You need a brain. That's all you need to do science, and we're all born with that. And for most of us, it's a functional brain, and we can use it to ask questions. And that's it. That's the minimum. And then you need the opportunity, and you need guidance, and you need determination, and hard work, and all of those things. But everyone is born with what's possible to pursue science. And I think if there's anything we want to communicate, is that science is accessible to anyone that wants to do it. But it takes hard work and practice. And the same with science communication. I think it just takes hard work and practice for figuring out how to not speak in jargon and to really try to get your point of voice across. And you have to want to connect with people in order to make it happen.
Yeah, then I have to say thank you, Rebecca, because I think that's definitely a compliment to Mandë and I. So thank you. I remember the feeling of like sitting in class and having the teacher speak at me and not understanding what was leaving her mouth. And I'm prominent in one language. That language is English, and I still could not grasp sometimes what was happening. And that feeling, that like pit in your throat and in your gut, that like, I want to learn this. I don't want to slow the whole class down by asking all these questions, or I have a question, but I don't want it to divert from the conversation, is a feeling of frustration. And so when I speak about my science, what I practice is I'm only as quick as my slowest player kind of mentality, where I want to make sure everyone's following this story. And those who are very high up, very high order, those who are the who are maybe do the same work that I do, if they tune out, they'll be fine if they tune in another 30 seconds because I'm explaining it too slow. But those who like really may have interest in it, but like if they don't understand, they won't make it to the end of my talk. Those are the people I really try to make sure that everyone's incorporated in. And it's I think that practice of also being home, my family, they're not scientists. My mom's from South America, Guyana. My dad's from New York, and I think coming from part West Indian family, they're kind of like, you're a doctor, so we're just kind of thing. So I've had to explain that it's a slightly different approach. Yes, I'm still in school, and the way this direction goes in a way that that they understand, that my friends understand, that other colleagues, other PhDs in my field who study something very small and very pigeonholed also understand, because I expect that from my colleagues as well. So just making sure everyone stays on board.
Yeah, that's a good point, because I remember being an undergrad and just not knowing a lot of what my teacher was saying and just feeling so uncomfortable and not wanting to ask him just because I thought I was the only one that didn't know what was going on. But I'm sure all the students didn't know what was going on. So
and as a teacher, you see that when you poll your students, you're like, oh wait, you guys are just staring at me while I talk. I need to change this for everyone's time.
Right.
I'm here with you for 40 minutes, a whole bunch of 12-year-olds. Let's make this work. And so I think
it's true.
Being a teacher too.
Yeah. So I have a question for you. What are your passions outside of the lab?
PG versions.
I enjoy talking about my science. Is that okay if it's still related to science? Because
that's fine. Absolutely.
I only do so much. So I would definitely say my passion is really science communication and storytelling. I've had the opportunity to do a few stories, like for example, Story Collider. I work now twice with sci-fi. I guess plus these times as well, and just speaking about the work that I do really is like my favorite pastime and hobby.
Hey. That's awesome.
I don't do marching band anymore, so that's it.
All right.
I like collecting old science equipment. So when I hear that a lab is closing down, especially a lab that's been around for like 30, 40 years, I try to get in there and see what they have that's really old, because everything now is digital and nothing has knobs or anything like that. And I really like the old time science equipment. I used to have it all decorating my apartment. And when I moved, my brother nor my boyfriend wanted to move any of them. And I'm like, please, you have to help me move this Geiger counter and, and these scales and all of these things. And
oh, no.
I really want to visit your lab. Mandy and
I decorate my lab with them. They're all over my office. They're in my lab. They're everywhere.
But those are so cool. I feel like they'd be
old science equipment.
Yeah.
It's just, and they're beautiful. They're really well made, and you can't
get them anywhere else. Right.
Them anymore.
Right.
It's like side thrifting. I like that. Like side thrifting. I go check out your side thrift, your side vintage.
Right.
It's true. It's good. They're beautiful stuff.
Mandy and I were talking on this Zoom right now, but Mandy, I don't know if you remember this. I met Mandy not in science, but at the park in Central Park. Yeah, exactly. Hi, at the time.
Oh, how long ago was that?
I mean,
pre-COVID.
3 years ago. Yeah, pre-COVID, 2.5 years ago. And she had mentioned she's a scientist. Like, oh, that's so cool. And then we had like cross paths. She left with her, your daughter, right? It was your daughter. I was like, I see her again. That's like so cool. Then I saw she was part of sci-fi, and I was like, look at this small world.
I know. I
never.
I was like, together. Where do I know her from? And I was like, you never have time before to do the searching. And I was like, afterwards, I have to ask her. I know we met. It's on the playground.
Hey. Too funny.
So right. I got your side vintage and your side thrift at some point.
No, hey.
Yeah, we have to. We have to.
So we have a question from Jennifer. She asks, some professors are teachers while some teach, so they can conduct research. Do you have a preference for teaching or research? And can you see yourself doing one without the other?
For me, my position is I'm both teaching and working at a research university. So I run my own lab, the Marlin lab, but I also teach. I haven't started that yet, but I'll be teaching undergraduates, graduate students at Columbia. I will say that some people work at what we call, for example, an example is like a medical center where you may not always have to teach undergraduates, but you'll teach graduate students, whereas people who work on an undergraduate campus may sometimes have a smaller lab, may run a big lab, but also have to teach. I will say that teaching comes in many forms. My doctoral studies, my PI did not teach undergrad, but he taught me. So he didn't have 60 students or 300 students twice a semester, but he had 7 that he invested in for 7 years. I'll be doing both, and I'm excited to do both. I can't see teaching without science because I think it's not correct. I actually think it's wrong. You can't have all this data, all this knowledge and not share it. But sharing, the way it's shared may look different. Sometimes it may be mentoring one person and passing on these skills and these knowledge. And another time it may be standing in front of a room of 300 freshmen and motivating them as to why the brain is something so amazing to study.
I 100% agree. I don't think you can have research or science without teaching. And there are different forms of teaching. So mentoring, if you have grad students, if you have postdocs, you have to mentor them. And that's a form of teaching as well. And I think that it's really important to tie the two. And this is where the science communication becomes key, right? And part of what we try to do with killer snails, I think it's imperative that we figure out how, especially for K through 12, we teach kids about science. It's knowing what we know after this pandemic year and looking at what's coming at us, you know, in the next 10 years, whether it's climate change or biodiversity loss or, global health, another pandemic, all of these things. It's important that kids understand that science and technology is a part of their lives and a part of their lives that is for their benefit. Science is a public good, and you can't do that and think that you can lock yourself up in your lab and not share your results with the public in more ways than one, than just putting out a paper. You really have to be able to teach, which is communication, basically, right? Because that's what teaching is. It's communicating your knowledge. It's exchanging ideas with people. It's learning by doing, sort of. And so you have to be able to marry the two. And I think the two are intricately linked. And it's how science started. And it's why, it's an apprenticeship. When you do your graduate program, you're getting your Ph.D., you're sort of being in an apprenticeship with the lab head. And so that person is teaching you the field. They're introducing you to what's going on and how, the field is going to go, and their ideas and your ideas will meld and come together. But you really cannot have research, I think, or cutting edge science without also having a teaching component to it of some sort.
Right. All right, so we're going to end with this final question. The videos that feature you highlight how your unique perspective and connection to science benefits the work that you do and makes your research better. What can you suggest for anyone attending today who may not know how to connect their everyday life with science?
I'll venture to say, if you follow your interest, it will happen naturally. Think about those things that after a talk, you really want to go back and dig into a little bit. Or at night, as you're laying in bed, you're kind of like, well, I wonder if. For example, with me, I have, as crazy as it sounds, it works for me. I have a waterproof pad in the shower, because that's what I do while I'm thinking. And sometimes I'm like, that's such a great idea. And I have a waterproof pencil and a paper pad, and I can jot them down. And then later on, I rip it out and write it in I have a notes in my phone, like a notes folder. I put these scientific ideas down of just my interest. And my interest in transgenerational epigenetic inheritance came about in grad school. I found a paper and I was like, oh man, there's an actual way to study this. Wow. And that was 6 years before I ever actually got to step foot into studying it. So those interests, they won't die. You can entertain many of these interests. Yeah. And when they keep on coming back up and being forceful, now I'm setting my whole lab up to study this. So I would say follow your interest, follow what makes you excited about science, and that naturally will follow.
Yeah, I concur wholeheartedly. If you're not excited about the problem, you're not going to pursue it. It's not going to work. It's not going to be something that you can do, which is sort of what I learned from my graduate degree and being at Rockefeller. The scientists there were all excited about what they were working on. And when I left there, I couldn't think immediately about what postdoc project I wanted to do. So I did some things in science policy and with the museum in science education, all the while sort of marinating, like Bianca says, you marinate on what it is that's my interest and what it is that you want to do. And then finally it was like, this is what I want to do. I want to bridge, the biomedical world with the natural history world. And I want to build a bridge for those two disciplines. And so when I had that idea, and then applied for postdoctoral fellowships and applied for postdocs, because I knew the question that I wanted to pursue. And it was knowing that question that gave you the desire to persevere, because science is also a lot of failure. Things don't work 100% of the time. and so you gotta have those outside hobbies, you gotta find something else to do, and you also have to, while you're doing those hobbies, be marinating about your question, because that's the thrill, right? The thrill of you know, like Bianca was saying, when she figured out, oh, these things connect and I can do socialization in this part of the brain and blah, 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 blah. That happened because it's all always in your head and marinating. And if you can't think about your question all the time and be excited about it, then you're not gonna stay, at least in academic science anyway. You can always go and do other kinds of science, which are very useful. But if your idea is to stay in academic science, you've got to find that question that really is a spark for you, because otherwise it's not going to work.
Right, right.
I will say I think about it like 38% of my time. I'm not going to say I think about my work 100% of my time. It's not 50.
You can't. You don't have that. No one has that luxury.
Exactly.
Right,
It's not
right.
38%, I would say.
One kid has the other, you know.
Yeah. And also sometimes you just need to relax. Like I watch a lot of like reality TV. I'm like, it's studying work because it's social. No, my brain just needs to quiet.
Absolutely. No, let's call it what it is. You're watching TV. Yeah.
Okay. You're watching TV.
Well, that's my other pastime.
You need to unwind. Yeah.
Exactly.
For sure.
Well, this has been such a wonderful discussion. Thank you so much, Mandë and Bianca, for joining us. And thank you also to our audience for attending. So once again, you can join the conversation online using the hashtags Breakthrough Festival or tag at 500 Women SCI and at SCIFRI. Tomorrow's topic is diversity in tech, and we will have Allison Marklin from the 500 Women Scientist Leadership Team. She will be interviewing Angelica Pando, who is a software engineer at Newzella. And you can still register for this event at sciencefriday.com/breakthrough festival. And so I just want to end really quickly with a quote from the late Dr. Marie Maynard Daly. She was the first African-American woman in the US to earn a Ph.D. in chemistry from Columbia University in 1947. And she said, courage is like, it's a habitus, a habit, a virtue. You get it by courageous acts. It's like you learn to swim by swimming. You learn courage by couraging. So thank you again, everyone, and have a great night.
Thank you.
Thank you. Thank you, Nicole. And thank you very much to Sci-Fi and 500 Women Scientists for hosting us today. This was a lot of fun. And Bianca, we have to meet again on the playground when it's
Hands down.
Right?
All of you. Thank you.